In this example, we are given 6 equations, and for each equation we're supposed to determine a linear equation from the graph. Before we look at any of these particular examples, it is important to note that I will likely rely on either the slope-intercept or the point-slope form of a linear equation. The standard form, the ax plus by equals c form, is not especially useful when working with graphs. But the slope-intercept, the y equals mx plus b, and the point-slope, y equals m times the quantity x minus x1 plus y1, are much more useful for these graphs. When I determine whether I'm going to use slope-intercept or point-slope will depend on what point I know about this particular equation. So let's begin with example A. Whether I'm going to use slope-intercept or point-slope, I definitely need to know the slope of my equation because both equations, both forms, use the slope. So to calculate the slope, I need to find 2 points on this line and find the slope of the line between them. Well, we're already given the y-intercept there on the y-axis at 0, -2. Or one other point I can see on this line is at 1, 3. So to calculate the slope, I'm going to calculate how much rise compared to how much run. To get from the lower point on the y-axis to the higher point, I see that I need to go up a total of 5 units. So that gives me a rise of 5. To go from the y-axis to the point there at 1, 3, I can see I have to have a run of 1. So when I consider the slope being the rise over the run, the slope in this case, m, is 5 over 1. But since the slope is just a fraction, I can reduce that down to 5. The other piece of information I would need for either point slope or slope intercept would be a point on the graph. Since in particular I'm given the y-intercept on this graph, I'm going to use that point, which means I'm going to choose to use the slope intercept. Now the point on the graph here is at 0, -2. So the b value for the slope intercept form is the -2 value. And putting this together, m being 5 and the b value being -2, I can state the equation of the first figure, figure A, as being y equals 5x minus 2. In figure B, I'm again going to start by first finding the slope. So that means I need to find 2 points on this line. Again, the y-intercept is already given to us, as well as I can figure out there's a point here at 6, 2. So to get from the y-intercept to the point over at 6, 2, I can see that I have a rise of -2, meaning I have to go down 2 units to get to the height of the lower point. To get from the y-axis over to the point at 6, 2, I have to have a run of 6. In this example, my slope, m, being the rise over the run, gives me a fraction of -2 over 6. But again, the slope is just a fraction, it's just a number, and -2 divided by 6 can be reduced down to -1/3. So I will use -1/3 for my slope. Again, I need to now decide if I'm going to use slope-intercept or point-slope form, but the fact is I do have the y-intercept given again. I can see the y-intercept here is at 0, 4, and again, the b value is the y value of the y-intercept, so the b value for my equation is going to be that 4 value. So putting this together in y equals mx plus b, I have y equals -1/3 x plus 4. In figure C, I again need to find my slope, and I have 2 points given on this graph. One is at -5, -1, the other is at -1, 2. To get from the left point to the right point, I can see that I'm going to have a rise of 3, and to get from that left point to the right point, I'm going to have a run of 4. So in this case, again the slope being the rise over the run, will give me that m is equal to 3 over 4. So now I have the slope, but I need to decide whether I'm going to use slope-intercept or point-slope form. Well, one thing I look at is when I look at the y-axis, I notice it does not cross over the y-axis on a grid line. It doesn't hit at a whole number. So for that reason, I don't know what the y-intercept is just by looking at it. And because of that, I'm not going to use the slope-intercept form. I'm going to rely on one of those 2 points that were given in the graph. So I have 2 options. There's one point lower down that we said was at -5, -1. There's another point over here that was a little higher up at -1, 2. The fact is that there is no single equation for this line. There's an infinite number of equations, depending which point you happen to use for your equation. If I were to use the -5, -1 and use the point-slope form, I would have y equals the slope of 3/4 times the quantity x minus the x value of -5, close the parentheses, and then add on the y1 value, the -1. If we go ahead and simplify that and write it down, we would have y equals 3/4 times the quantity x plus 5, close parentheses, minus 1. It's important to note there, the x plus 5 came from the fact that I'm subtracting a -5, and subtracting a negative number is equivalent to adding. Now the fact is, we could also have done this with the second point, the point there at -1, 2. If we had used that point, we would have had y equals the slope 3/4 times the quantity x minus -1 plus the y value of 2. But again, we don't like leaving minus a negative number in any sort of equation, so we're going to simplify that. And so this would then simplify to become y equals 3/4 quantity x plus 1, close parentheses, plus 2. Continuing on with figure D. In figure D, we need to do the same thing that we've just been doing. First find the slope, then determine whether we're going to use point slope or slope intercept, and that depends on what point we have on our line. Well, in figure D, I'm going to pick 2 points. I see there's a point on the graph at 2, 2, and I see a point at 6, 6. So to get from the point 2, 2 to the point 6, 6, I first need to go up 4 units, and I need to go to the right 4 units. So that gives me a rise of 4 and a run of 4, and my slope becomes 4/4. And if we reduce that, that becomes 1. So that is a line with a slope of 1. Now to determine whether I want to do point slope or slope intercept, I first look at the y-intercept. Can I determine the coordinates of that point exactly? Well, in this particular example, I can see the line goes straight through the origin. And the coordinates of the origin I know. That's 0, 0. Knowing the y value of the y-intercept gives me the b value for the equation. So the equation of this line in slope-intercept form becomes y equals 1 times x plus 0. But we would simplify that down to just y equals x. In figure E, again we have a line. I can pick 2 points on that line to find the slope. So I'm going to pick a point here at -4, 5, and over here at 2, 5. Which 2 points I pick does not really matter. It just gives me enough space that I'm not cramped, and I can easily write down how much rise to how much run. Well, in this particular case, to get from the point at -4, 5 over to the point at 2, 5, there is no rise. The second point is neither higher nor lower than the first point. So in this case, the rise is 0. And since I have no way of actually drawing that, I'm just going to write rise equals 0. Now I can talk about the run. To get from the left point to the right point, I see that I'd have to go over 6 units. So that gives me a run of 6. When I put that together, that gives me a slope, an m value, of 0/6. Well, 0 divided by 6 is 0. So in this particular case, my slope is 0. It is important to remember a horizontal line will always have a slope of 0. In terms of the y-intercept, I can identify that from the graph. I can see that it crosses the y-axis at 0, 5. So since I know the slope of 0 and I know the y-intercept 0, 5 gives me a b value of 5 for my equation, I am able to use the slope-intercept form. So my equation becomes y equals 0 times x plus 5. Now if I simplify that, 0 times anything is going to become 0, and so this equation will become y equals 5. The truth is, that was a very long way to get to that equation. What we really want to recognize is anytime we are dealing with a horizontal line, the equation will always be y equals some value. Because you'll notice, when I talked about the first point had a coordinate at -4, 5. And the second point I used to calculate the slope was at 2, 5. You'll notice all 3 of those points, -4, 5, the y-intercept at 0, 5, or the other point at 2, 5, all have a y-coordinate of 5. All horizontal lines will always have the same y-coordinate, and that y-coordinate that is common for all the points is the equation of your line. Y equals whatever that number is. If we try to approach figure F using the same method that we've used on these first 5 examples, we would start off in the same way. We'd pick a point here at, say, -2, 1, and another point at -2, 6. And I'd first measure the rise. Well, to get from the bottom point to the top point, I need to go up 5 units. And so I have a rise of 5. But in terms of a run, a horizontal distance between these 2 points, there is no horizontal distance. So in this case, I have a run of 0. So I have a rise of 5 and a run of 0. That gives me a slope of 5 over 0. It is important to recognize the difference in these two fractions from figure E to figure F. 0 divided by 6 in figure E is equal to 0. 5 divided by 0 is undefined. So in this example, we would say that this line has an undefined slope. There is no number that I can put onto that particular slope. Because the slope is undefined and I can't write it as a numerical value, neither the slope-intercept nor the point-slope forms are going to work, because I have no value to substitute in for the m. So we need to approach this slightly differently. Let's take a look at the 2 points that we started with. The first point was at -2, 1. The second point was at -2, 6. If we pick a third point down here towards the bottom, we would see that we have a point here at -2, -5. What you should notice with all 3 of these coordinates, and any other point that you would pick on this line, is that it has the same x-coordinate. The x-coordinate for all 3 of these points is -2. Similar to horizontal lines like the one in figure E that always have an equation y equals a number, vertical lines that always have the same x-coordinate have the same sort of equation. This would be the equation x equals -2. And again, just to re-emphasize, all vertical lines will always have an equation that is x equals a number, where that number is the x-coordinate from every point on the line.